Assalamualaikum and good day to everyone. In today's lecture, we are going to complete the chapter for the meat manipulation. So this is the last four syntax that we are going to learn and test it by using our Easy68K. In this topic, we are going to learn only four of them, which is related to the bit manipulation. We are going to test. We have to clear or set to test change. This is quite simple, as when you look at the command here, you know that what is actually going to execute on the code itself. So there are four of them. The first one is the bit change. The second one is bit clear. The third one is bit set, and the fourth one is bit test. So all of these syntax will relate to the Z flag. You remember that we have the flags last time, so we have the X, B, C, and Z. So this one will be impacted for all these syntax. Okay, so in these instructions, right, what it's going to use, what it's going to execute is when you want to do the bit change. Okay, it's going to change the bit, and it will going to test first. Okay, test and change. This one test and clear. Okay, test and change, then test and clear, test and set it to 1. This is clear, set it to 0, and this is only to test only, and you're going to look at the Z flag here. So all of this is going to look at the Z flag and do the task. Okay, Z flag. Let's look at the example one by one. So the syntax will be like this. You have the bit change. You can put data register first, and then the next one is effective address anywhere, or the other pattern is the other syntax. You're going to put a number here, and you have the effective address over here. It can be any data register, or it can be a direct indirect memory. It's up to you. So this is the syntax that we are going to learn and use in our Easy68K. So we have this all four of them. Okay, it's the same syntax anyway. Pattern is the same. Okay, the condition codes, only Z flag is going to be affected. Z flag is set. Okay, what is going to do is going to test first. Okay, it's going to test the code, the bit first, test, and then look at the result. If you have the test bit is 1, then your Z flag is going to be 0. If your test bit is 0, then you can see that your Z flag is going to be 1. This is the concept. Okay, so Z flag is set. Okay, Z flag is set if the manipulated is 0. So this is the one. Z flag is set if the bit manipulated is 0, cleared otherwise, cleared otherwise. So Z flag is equal to 0, then you're going to set it as 1. Cleared otherwise, if it is not found to be 1, then you have the Z flag is going to be 0. Okay, so this is the actions or the definitions details on that. So for the bit change, okay, the bit change is the first one. It will test the bit. Okay, test the bits and set the Z flag accordingly, and then change the bit. So change means if the condition is 0, then you have to change it to 1. If you have the bits is 1, then you have to change it to 0. This is you test first, and then accordingly you have to know that the syntax will change the value, and prior to the test you have the Z flag tested, you know already. So it's going to be what is either 0 or 1 based on what is the number. Okay, then you have the bit clear. Bit clear means test a bit. Okay, test a bit in the destinations and sets the flag accordingly. Again, you will test the bit. So you will test a bit over here. Test a bit. then you can get the Z flag. Then it will clear, means that whatever number 1 will be 0, 0 still will be 0. Okay, then the next one is bit set. You also do the testing here, test the bit, then you can get the Z. Okay, the Z value here. Then the number will be set, 1 still going to 1, and then this is 0 going to 1. Same goes to the last one. This one will be test the bit, and then you can see that you can get the Z flag, and then this is only to about the bit test only. So the command here is to look at the result on the Z only. Okay, there's nothing changes on the bit itself. So they test a bit in the destinations and sets the flag accordingly. No change to the tested bit. Okay, let's try looking at the example here. Okay, given the address, this is the value of the address. Okay, you have to imagine that this is the address here. Example here, this is locations FF800, and the content data is $AA. Okay, what is the effect of the instructions of bit test number 3 at this location? You can see that this is directly $, no hash, means that it refers to the memory locations. So you're going to test bit number 3 in these locations. That you have to find out the data. The data is AA over here. Okay, so AA is like this. In binary, you know that this is A, this is A. Okay, this is bit 0, 1, 2, 3, 4, 5, 6, 7. So bit 3. Bit 3 is this one. Okay, the command say bit test number 3. So you testing over here, you test this one. So you find out that the value here is 1. Okay, means that your Z flag will be is equivalent to 0 because your bit value is 1. If your bit value is 0, then your Z flag will be 1. Okay, let's try first this example in Easy68K. Okay, I'm going to put the value here at the location first. Define constant dot long, origin first. Origin $FF8000. Okay, define constant dot long, then you need to put the value here. You didn't put the long here, you just put byte because you only want to put a value over here, AA. So the command is bit test BTST number 3 to that particular locations area $FF8000. Okay, so this is the one. So let's look at the results on the command. Okay, so you're going to test this one, bit number 3 here at this one. So you're expecting the value at Z here still to be 0. Let's try to redo it. Now this is going to run this command, bit test. So there's nothing changes over here. This is all 0. And the contents at the location FF8000, still there's no changes because it's only testing just to validate the value. Okay, the contents at FF800. So you can see that the value is still at AA. Okay, so this is the first example. Let's try to change the example. To look, the value here is going to be 0 instead of 1. So let's try to change the value here. Instead of AA, so if you want to have this value to be 0, so this is going to be A and 2. Okay, the contents now should be A and 2. Okay, now let's try to look at your Easy68K. Instead of AA, you are changing it to A2. Okay, now you can try to test it. Okay, run this one. Before that, you're going to look at the memory here. A2 is already put at the memory locations FF8000. Look at the Z flag here, still 0. Let's try to run this bit test. Now you can see now the value of Z is equivalent to 1 because at that particular bit, this bit is not 1 anymore. This is 0. So when you test a bit is equivalent to 0, then remember that your Z flag will be 1. If the bit is 1, then your Z flag will be going to be 0. Okay, that is for the bit test. Very simple because there's no changes on the values at this location. So let's try another one. Bit clear. Okay, bit clear. So I don't want to use this example. You're going to use the same example like this. So you can try by looking at the other example by having this value put into your Easy68K. So I'm going to put bit clear. Okay, bit clear. Instead of having the bit test over here, okay, I'm going to put the same value here. Now we are going to use bit test or bit change. This is a bit clear, right? This is bit clear. Okay, the value is number 3 to the location FF8000. So now I'm going to clear bit number 3 here. Okay, based on the location here, what's the content? So this content, the first one just now, we have the AA version, right? So I'm going to change it back to AA. Okay, this one back to AA. And then I'm going to use the bit clear instructions, bit clear number 3 at the locations AA. So let's run that one. So now your AA is this one. Bit number 3 is this one. Your bit now is 1. This command is to clear the bit, means that at the end of the process, you are expecting this value to be 0. And prior to that, you have to test the bit first. Remember that you have to test first. And then when you test, you can see that the first value you can find out here is 1. If the test value is 1, then your Z flag, okay, again, sorry. For this one, for the AA number, so if you want to do the bit clear, all right, number 3, you're going to test this value first. This is the bit number 3. Okay, bit number 3. And you have to test it first. So the initial value for that one is 1. So now your Z flag is going to be equivalent to 0 because the test is going to be 1. Now your Z is equivalent to 0. Okay, so after that, after the command completed, this value will be changed to 0. This is going to be cleared to 0. Okay. Okay, now we are going to try in our Easy68K. Bit clear number 3. Okay, FF8000. So let's run this one. Okay, now look at the view of the memory. AA over here. So you are going to test it. You are so expecting number 3, bit number 3 is 1 just now. So you are going to expect the Z value is going to be 0. So you run that one. And look at the view of the memory. Now the memory now go back to A2 instead of AA just now. So what happened? So in here, right, after you complete the instruction, okay, this value will be changed to 0 and it is cleared. So now you have this one A, this is going to be 2. So the final result for the particular location 8000 is going to be $A2. Okay, you test it and you clear it. Okay, let's like to look at another example. This is bit change. Bit change is going to change the value. anyway. Okay, so again, I'm going to use the same example here. Okay, this is going to be bit change. Just now is bit clear, right? Okay, bit change, bit number 3 to this location, the contents of this location. Okay, this AA is equivalent to this one. Bit number 3 is this one. So the first step is to test the bit first. Okay, the testing will test this one. So it finds out that the bit number 3 is equivalent to 1. So your Z flag is going to be 0. Then it will change. It will change the bit no matter what. This one from 1 go to 0. Change means if the initial value is 0, then you have to change accordingly. You have to complement it. Okay, so let's try for the bit change. I'm going to have the result again at A and 2, the final result, and your Z flag is still equivalent to 0. So let's try to look at the example. Okay, instead of bit clear, we're going to use bit change. Okay, number 3. Let's run this one, execute this one. Look at the contents at the memory, AA. Now you're going to test and change it. Look at the Z flag over here. Okay, where's the code? Sorry. Windows here. Okay, the memory is here. I just want to put it here. So the memory at this location now is already moved to A2. Your Z flag is still equivalent to 0 because the testing is equivalent to 1 just now. So let's try to change it. Okay, instead of AA, I'm going to change it to A2. This is the initial condition. Means that your bit 3 now, is not more 1010 1010. Your bit 3 now is going to be 1010 0010. This is 2, this is A. So this is condition that I want to meet at the first in the beginning of the EZ60AK launching. So I'm going to put it A2 over here. So this command will test the contents at bit number 3 and change the Z flag. And after that, we're going to change the value from the bits. Okay, change again. So the first value is AA. Okay, let's run this one. Okay, let's look at the memory. Okay, now look at this value 3 to this one location. So run this one. Now you can get the result is AA. Your Z flag is equivalent to 1 because you test the bit just now. The initial condition just now is A2. When you test this value, you're testing the third bit here. The third bit here is tested. It found 0, so your Z flag is going to be 1. Z flag is going to be 1, and then it will change the value here from 0 to 1. Then that's why you can get the result final just now is AA, and your Z value is equivalent to 1. So that is for bit change. Okay, let's move on. The last one is bit set. Okay, that's the last one for bit set. So let's try again on the command just now, the first command. So if I want to use the same command here with the same value, so we're going to use it for bit set condition. Bit set. Okay, number 3 to the location. Okay, now the contents of these locations, you are going to take AA, and the bit number 3 is 1. So bit set means you have to test first this bit, and then if you find 1, your Z is going to be 0, and after that you have to do the set on the bit. Okay, set on the bit means you're going to change it to 1. Now the condition is 1, still the value will be 1. Okay, there's no changes here. That the final answer for the memory must be AA, and your Z flag still equivalent to 0. Let's try to test it on your EZ68K. Okay, instead of bit change, now it's bit set. Number 3, FF is you, the content for this one. So let's look at the results. Okay, AA here, so this is going to be Z, right? Z. There's nothing, Z is going to 0. So let's run this command. There's no changes here, there's no changes in Z. Okay, let's try to change the value to another value, to A2 again. Now I'm going to set the value, okay, here. Okay, let's instead of AA, we're going to have it as A2. A2. A2 means that this is going to be 0. Okay, A2. Okay, bit set, bit number 3. Okay, it tests this one first. The Z tested is 0, then your Z flag is going to be 1. And then this is going to set the value at bit 3. So what happened here, from 0 is going to be changed to 1. So the final answer is going to be 1010. This is going to be A. Final answer, the location will be AA. So let's try to look at the bit here. Okay, now this is going to be A2. Okay, bit set. Let's test it. Okay, now you can see the Z flag is changed to 1 because it tests the initial condition of the bit is 0. Then it will change the contents from A2 to AA. Okay, so that's for the bit set. So that's the 4 example that I have. So you can have look on the example in the chapter, in the slides, or also in the book that we have. So that's where you can find out all the examples for these 4 particular syntax. This is quite easy syntax anyway. Okay, that's all for this particular topics. Thank you very much.